Flapping flight is one of nature's most efficient marvels. But how do we make a robotic butterfly flap with the same grace and efficiency as a real insect? Today, we're looking at a brand new control algorithm, built directly on the principles of classical 2D animation. Traditional flight controllers usually use a simple, symmetrical sine wave. But according to the famous animator Richard Williams, natural flapping isn't symmetrical. In fact, the wings should linger near the top at the start of the downstroke. This is represented by frame 2. By keeping the wings high for longer, we maximize aerodynamic lift and minimize mechanical stress during direction changes. In our flight controller firmware, we implemented this with a new wave function, wave equals sine minus 0.5 times cosine squared. If you look at this chart, the blue dashed line is a standard sine wave, which crosses neutral at frame 2. But our new formula, the pink line, is still hanging high at plus 30 degrees. That's a massive 50% high dwell delay, creating a true asymmetric stroke. We can see this in action inside the real-time simulator. As we push the throttle, notice how the wings dwell at the top of the stroke, and then snap down extremely fast. This high-speed snap is what generates the intense downward airflow required for stable flight. Back on the ground, you can easily calibrate your left and right servo offsets through our web-based configurator. The new algorithm runs entirely in the background, so you don't have to manually tune any asymmetry values. Just set your offsets, click Save, and the firmware handles the rest. A quick safety tip before you fly: because of the high-speed downstroke, your servos will run a bit hotter. Keep an eye on temps and flight times. Always verify your Channel 5 safety arm switch before powering on. Now, get out there and enjoy the flight.